Hey everybody, it's Mr. N here, and we are going to do the chain rule today. So let's take a look at what we got going on here.
And this is 3.5 in Stewart's 6th edition, but 3.4 in the 9th edition.
And basically, to be honest with you, you have been using the chain rule this whole time. However, our chain has just been the value of 1, so you've been multiplying by 1 and it hasn't made a difference in your answer. But suppose we had something like this, where this time, imagine if I had this equation, 2x squared plus 3 to the second power. And you can't take the derivative to be this. You can't do that. This is not the right answer, and here's why. If I actually FOIL this out, okay, I get 2x squared plus 3, 2x squared plus 3. And I use a product rule. First times derivative of the second plus the second times derivative of first. Or FOIL the whole thing out and get one long polynomial. And you take the derivative, you end up with this situation as your answer. You have an 8x here. Wait a minute. I didn't have an 8x there, so let's take a look. Let's take a look. Over here, I had this 8x that came up in my answer, and over here I had nothing. So that's why you cannot just do it in this method and come up with that answer. There's something more involved in this, and it's called the chain rule. So right here, we've got our chain rule, and let's talk about what the chain rule is. If f is differentiable at x and f is differentiable at g of x, then the composite, okay, so a chain means that we have a composite. F of g defined by f of x equals f of g of x is differentiable at x, and f prime of x equals, okay, here is what the chain rule tells us, so let's pay attention to this. F prime of x will be f prime of g of x, which was our original, and then I have to multiply it by this thing. This is called the chain. Oops, let's use the other. This is called the chain. So it's what it was on the inside. So I have to take basically the derivative of the original function and then derivative of whatever's inside the function, whatever that composition is. So in Leibniz notation, what we're doing is if y equals f of u, and you don't make fun of that, and u equals g of x, and both are both differentiable, then dy dx equals dy du times du dx, because what happens is you get that, right? But that's the situation there. So here's basically, in layman's words, what I'm trying to tell you. You take the derivative of the outside, and then you multiply it by the derivative of the inside. So going back to our original example, the chain rule is kind of a little bit more complex than this, and we'll get into the nitty-gritty of it. But suppose I had this basic example, okay? F prime of x, and I said take the derivative of the outside. That would mean this box right here to the second power. So this would be 2, and then whatever I had in this box, which was the 2x squared plus 3, you leave that, 2x squared plus 3, and then this obviously becomes to the first power. And now I take the derivative of what's inside this box. And what's inside this box is 2x plus 3, and I take 2x squared, sorry, and I take this derivative, I get 4x. So then the final answer becomes 8x times the 2x squared plus 3. Okay, so this was 2x squared. I made a boo-boo and didn't write the 2 there. You can combine this with the power rule, and you get d dx of u to the n equals n unit, and then I'm multiplying. This is the chain right here. That's the part that we call the chain. Again, if it looks like this, you're doing this, and then the inside is called the chain. So let's take a look at a few examples that we have here, starting with these, and we need to find f prime of x. So on this first one, when I take this derivative, I'm going to do this part first, right? Right here. So negative 2, x plus 1 to the negative 3, I subtract 1. So this is like my box, which I just kind of ignore for now, just it goes along for the ride. And now I need to multiply it by the chain, which is the derivative of that inside. Well, the derivative of the inside is just 1. So f prime of x ends up being negative 2x plus 1 to the negative third power. Yes, you can write it as negative 2 over x plus 1 to the third power like that. Either way is correct. All right, look at the next one when I have this situation with sine. All right, so for this one, I'm going to take the derivative. Now, before I do that, though, let's rewrite this as the sine x, and it's going to be to the fifth power. So this is like my box to the fifth power, and I just do the normal derivative there. So this would be f prime of x equals 5, and I have this box, right, to the fourth. And in here I had sine x. Now I have to do the chain, which is taking the derivative of what's inside that box. And the derivative of sine x would be cosine x. So over here, I end up with 5 sine to the fourth x, like that, cosine x. So all these are multiplied by in between. You don't have to put the multiplication symbol, but you can. And that's your final solution there. All right, let's take a look at the next set of examples we have. Find the derivative using Leibniz notation. So using Leibniz notation is just the whole d over dx. So let me break these down. Leibniz tells me that I need dy dx to be this dy du times my du dx. Okay? So what you can do is you can, remember how I did the box on previously? Well, it's the same type of method. You're going to let u equal this box. So we're going to let u equal this 2x squared plus 3, whatever was inside that box. Okay? So now, y will be u squared, right? It's the box squared. Y is this box squared. And this box, we renamed it to be u. So now I'm going to take the derivative over here, and I've got du with respect to x as being 4x. I'm going to take the derivative here. dy with respect to u, because that's my variable, will just be 2u. And now I'm applying it as dy dx. This becomes dy du, which is 2u, times du dx, which I found to be 4x. And this gives me 8x times the u. And now I resubstitute, and I'll get 8x, and my u was this 2x squared plus 3. That's how we do it using Leibniz. Often when we do more things using this, it's called a substitution rule, but let's just save that for later. Let's do the next one. Okay, so remember, Leibniz, I need the dy dx equals du times my du dx. Okay, so this is what's my box right there, right? So that means I'm going to let u equal this box, which was 3x squared plus 1. And that means y would equal the tangent of u, which is the box. Let's take the derivative here. Du with respect to x, because it's x right here, that's why I'm respecting it to x. This would be 6x. dy, this is a u, so I'm going to take the derivative with respect to u, would give me secant squared u. Plugging these into the Leibniz right here, I get dy dx becomes dy du, so secant squared u times 6x. Now I make my substitution, resubstitute, and I'm just going to rewrite it like this, 6x times the secant squared of this stuff, which was the box, 3x squared plus 1. And I'm referring to the box because that's what I'm just calling this in here my box that I'm going to just kind of keep along there for the ride. All right, let's do some more. Like I said, we're not going to do Leibniz on these next ones. Leibniz notation may seem a little difficult, but later when we do something called integration, we're going to use it, and it really helps us with something called a substitution rule. So it's good to know, and you do need to know it later. All right, so over here, let's do this next one. And on the next one, it's saying just find the derivative. So f prime of x is going to be 7. Here's my box, so I just keep this what's there. I don't need to change that at all. And to the 6th power. Now I have to chain rule it, so I multiply what's inside this parentheses. So again, it's like a box. Ignore this to the 7th power. Just take the derivative of that. You get 7, this box, to the 6th, and now I have to multiply it by the derivative of what's in that box. So that would be 2x minus 3. So f prime of x equals 7 times the 2x minus 3 times this x squared minus 3x plus 4, plus 4 to the 6th power. You could, if you wanted to, distribute this and say 14x minus 21, and then keep this as x squared minus 3x plus 4, but by no means do you want to FOIL that out to the 6th power. That's just a waste of time for this class. Okay, moving on to the next one. Over here, capital F prime of x. This would be negative 1, and you keep this over here. What's in here, just leave it alone, to the negative 2. Times, now I'm going to chain rule this. So over here, the derivative here would be 1, and this would be minus 1x to the negative 2. Okay, so f prime of x would give me, and I'm just going to rewrite this a little bit. Actually, I'm going to rewrite it and see what we can clean up. Let's see if we could try to simplify this one a little bit. So I will rewrite this to say negative, and I'm going to say 1 minus the 1 over x squared. So basically this part right here, this is what I was looking at. On this one, it's going to be, and this negative 1. On this, it's just going to be x plus 1 over x squared. And if I find a common denominator on the top and manipulate it a little bit, I will get 1 over x squared. Actually, just distribute the negative first. We're going to multiply everything by x squared over x squared. Let's just distribute the negative first. Over here, I'm going to FOIL this one out. I'll end up with x squared plus 2 over x plus 1 over x squared. And then I'm going to multiply here, like I said, the top and bottom by x squared. That'll clean it up a little bit better. And then I'll end up with 1 minus x squared all over x to the 4th plus 2x plus 1. And you can leave it like this. All right. This one actually factors on the bottom. If you really wanted to take that step further, that would be x squared plus 1 squared like that on the bottom. All right, next one. Ooh, this one's kind of interesting. Let's take a look at what we got. We have a chain rule where this is my box right here. So I'm going to take f prime of x here, derivative, and I'll take the derivative of this cosine, which would be negative sine, and I keep my box here, right? And now I got to multiply by the derivative of what's inside that box. So this would be negative sine, and this is cosine x, right? That's the box, times the derivative of cosine x is another negative sine x. So f prime of x, now I can clean this up. These two negatives become a positive. But remember, this sine is attached to this cosine. So I just have to write it as sine cosine x times sine x, like that, and leave it as is. Moving on to the next one. Over here I'm dealing with a tangent. Remember, this is like my box that I just ignore. Take the derivative of the tangent, and this would be secant squared of this box. And now I have to take the derivative of this box. Okay, so f prime of x becomes secant squared, and this was 4x squared in here. Now I take the derivative of this times, that would be 8x. So rewriting this, I get f prime of x equals 8x times secant squared 4x. All right, moving on to the next one. Let's pick another color here. Let's go back to this blue. All right, over here I've got that right there, but ooh, look at what I got going on. This one's a little crazy. I've got a chain inside a chain, believe it or not, with a product rule. So this is a product rule and the chain rule all put together here. So let's take a look at this. F prime of x will be first times the derivative of the second. First times the derivative of the second. Now when I take the derivative of this, I'm going to have to start off with this. Let's rewrite this as sine 5x squared. So I have the outer box. Then I've got an inner box, which is that 5x. I've got a chain inside a chain. So let's do that. Let's do the outer box. So that's 2. Remember, the outer box is this thing, sine 5x, okay, to the first power, times, now I have this sine that I got to take the derivative, which is cosine 5x, times, now I have to take the derivative of that, which is 5. Right, so this is the inner box in there. Right there. So that was first times the derivative of the second, plus the second, which is this sine squared 5x, times the derivative of the first. Well, that one's easy. That's just 3x squared. All right, so kind of like ran out a little bit of room there. But I will do another one for you just like that in a second, just to kind of hammer the point home here. So now let's see what I can combine. The 5 and the 2, I'll get 10x cubed. And I use that, and I'll have, and I use that, so I have these two things left. So sine 5x, cosine 5x, sine 5x times cosine 5x. Plus, over here I've got 3x squared, sine squared 5x. Now you could take this a step further and take out an x squared. No, we're not going to. We'll just leave it at that. Okay, here's the other example I said I would do for you. So let's write this down. Let's say you had f of x. This is another example I'm adding on. And we're just going to do a basic one here. And we're going to say cosine 3 to the 2x to the 4th power, like that. Okay, to take this derivative, f prime of x, first let's rewrite this. Let's say this is cosine 2x to the 4th power, right? And this whole thing will be to the 3rd, like that. See what I did? So when I take the derivative, remember, you're working from your outside to in on this one. So we're going to say 3 times this stuff squared. Then I got to take the derivative of this stuff. Well, what's in there? You have the cosine of 2x. Well, I've got the cosine of this box right in here. So that would give me negative sine of this box, which is 2x to the 4th. Now I got to take the derivative of that box, which is 8x. So here you have multiple chains going on. So f prime of x ends up being this 8x, and the 3 gives me 24x. And now I'm just going to rewrite these things. This was this whole box over here, which was the cosine of 2x to the 4th squared times negative sine 2x to the 4th, like that. Okay, so that's times negative sine. So you had a box inside a box inside a box, kind of that situation. All right, let's take a look at this last one and see what we got. If f of x equals this, and g of 3, g prime of 3, f prime of 3, f prime of 6, we need to find f prime of 3. Well, let's see first how we can do f prime of x. So for this one, to find capital F prime of x, I have a chain rule going on. Remember, I work from outside to inside on this. So that would give me f prime of g of x, and now I have to take g prime of x. Okay? So if I wanted f prime of 3, this would be f prime of g of 3 times g prime of 3. I forgot a parentheses here, sorry. These were in parentheses, so here's my g of 3, and then that's g prime of 3, substituting that in. So now it gives me f prime. Okay, well, what's g of 3? G of 3 is 6, times what's g prime of 3? G prime of 3 is 4. So now I need f prime of 6. F prime of 6 is 7, times this 4 gives me a final answer of 28. All right. When we meet together in class, I'm going to go over more of the importance of the chain rule and applications of it. But hopefully these are the basics, how to do it, why we do it. So hopefully you liked it, hopefully it worked out, hopefully you understood it. So hit that like and subscribe button, and I'll see you guys in the next video.